All right, let's dive right in. Today, we are getting to the absolute core of how AI systems generate what they generate. We're talking tokens, distributions, and what reliability really means. And trust me, understanding this is going to completely change how you think about these tools. So let's kick things off with something that trips up almost everyone. You know that feeling, right? You ask an AI a question and you expect the answer, the one single correct answer. But what if that's the wrong way to think about it entirely? Yeah, they're not answers at all. It's a really common mistake to think of these models like a search engine, just pulling the fact out of some giant database. But that's not what's happening. And once you get what is happening, everything about how they behave starts to make a whole lot more sense. Okay, so that brings us to the first big idea we need to unpack: sampling from a distribution. We've got to shift our thinking. We're moving away from the world of concrete answers and into the world of probabilities. First things first, let's talk about the absolute basics. A language model doesn't just think up a whole sentence and spit it out. Nope. It actually builds its response one little piece at a time. And these pieces are called tokens. Now, a token could be a whole word, like system, or it could be just a part of a word, like the ing at the end of talking. Okay, so how does it pick that next token? Well, for every single step, the system basically creates a huge list of all the possible tokens that could come next. And not just the tokens, but the chance, the statistical likelihood of each one being the right fit. It's like a big statistical map of what's most likely to come next, all based on the patterns it's learned. And this right here, this is the absolute key to everything. The system is not searching for one single correct word. It's looking at that whole distribution of possibilities and then sampling from it. It's picking one from a range of likely options. So now that we know it's all about probabilities and sampling, what does that actually mean for us when we're using these things? Well, that leads us right into why outputs can be so different. And you'll see that this variation isn't a bug. It's actually an expected part of how it all works. I mean, we've all done this, right? You put in the exact same prompt 2 times in a row and you get 2 different responses. It's easy to think, is this thing broken? But it's not. It's just doing its job. It's sampling from that probability distribution again. It's kind of like rolling a pair of dice. You wouldn't expect to get the same number every single time, would you? Same principle. And what's really cool is that the shape of that probability list, that distribution, totally changes the kind of output you get. So if you have a really wide distribution with tons of different viable options, you get results that feel, creative. But if that distribution is really narrow, with just a few super likely choices, the output feels much more precise and consistent. And here's the thing, neither one of these is automatically better. It completely depends on what you're trying to do. If you're brainstorming ideas for a story, you probably want that wide, creative distribution. But if you're asking it to summarize a report, you're going to want that narrow, precise one. For a lot of assistive tasks, a little bit of variation is totally okay. Okay, so you're probably thinking, got it. If I want a precise output, I just need to write a better prompt. And, well, that's not the whole story. This brings us to a really, really important distinction between influencing the output and actually controlling it. Pay close attention to this one because it's huge. Your prompt is an amazing tool for influencing that probability distribution. A really well-crafted prompt can push the model in the right direction. It can make certain outcomes way more likely, but it cannot control the outcome. It can't guarantee it. So if you're chasing true reliability, just writing better prompts isn't going to get you all the way there. So if the perfect prompt isn't the silver bullet for reliability, then what is? And that brings us to the big idea of this whole explainer. Reliability is a system. Real, predictable behavior doesn't just come from the model in isolation. It comes from the entire system that we build around the model. Think about it like this. A truly reliable system isn't trying to force the model to produce one specific pre-written answer. Instead, the goal is to systematically constrain that distribution of possibilities. It's about building guardrails that narrow down the options, making sure that whatever the model samples is going to be acceptable and useful for what you need. So how do we actually do that? How do we build those guardrails? Well, the model itself is really just one piece of the puzzle. The real control comes from all these other layers that we build on top of it. Things like very specific instructions, safety policies, data that we feed it for context, even how we configure the sampler itself. These are the real control knobs that let us shape the final output. Let's make that a bit more concrete. You can have system prompts that set the fundamental rules of the game.
You can have policy constraints that just flat out block certain topics. You can use something called retrieval injection to force the model to base its output on specific documents you provide. This is the engineering. This is how you build a reliable system.
And all of this leads to our final and most important takeaway. I want you to really let this one sink in. Reliability is a system property. It's not about finding a magical new model, and it's not just about becoming a prompt wizard. It's an engineered feature of the whole setup. Think about safety in a car. It's not just the brakes, right? It's the brakes, plus the airbags, the crumple zones, the seat belts. It's all of those things working together as a system. That's what makes a car safe. And seeing it this way completely reframes the challenge for us. The really important question isn't, how can I write a better prompt? The question becomes, how do we design, validate, and govern the constraints of the system to get predictable behavior? Figuring that out, that is the absolute key to building AI we can actually trust and rely on. Thanks for tuning in.